Hello everyone, and welcome to this example recording on charge, current, and voltage. So the question that we're going to be looking at in this example is going to read as follows. It reads, a battery may be rated in ampere hours, and a lead acid battery in particular is rated at 160 amp hours. Determine the maximum current that it can supply for 40 hours, part A, and part B, how many days will it last if it is discharged at 1 milliamp? Right, so one of the key points to remember when dealing with batteries, doesn't matter which type of battery it is, you've got your gel-based battery, lithium-ion battery, you've got your lead-acid battery for interest sake, is that the ratings are usually given in either your amp hours, so they'll give you the voltage to a certain value, and then they're going to give you the rating of the capacity of energy that the battery can have in terms of amp hours, so the current multiplied by the hours. So the amp hours of the battery would give you a certain value, right? And you should be able to see that when you multiply the voltage by the current, you get the power, and then if you multiply the power by time, you get energy, right? So the rating will either be in amp hours or the rating will be in kilowatt hours, one of the two, right? But that's just for interest sake. So now looking at this question, we are being told that the battery is rated at 160 amp hours. So this battery has a capacity of 160 amp hours, which can be seen in different ways. So depending on whatever current you draw, how long you can draw that current will then will get you to this 160. So for example, if you decided that you want to draw maximum current, which is 160 amps, then you can only do that for 1 hour, so that you can have a total of current times the time, which will be 160 amp hours, right? And likewise, if you decided to draw half of that, so if you decided to draw 80 amps, right, so you can draw that for 2 hours to get to the 160 amp hours. So this is typically how this would work. But the battery will have a maximum current limitation that it will indicate. So in this case, they haven't indicated that. So part A requests you to determine the maximum current that can be supplied for 40 hours. So we know that 160 amp hours is equals to the current, so I'm going to say current multiplied by the number of hours, which is 40. So the current that we're looking for will then be equal to 160 divided by 40, and that should give us a value of 4. Right, so the current I will equal to 4 amps. I can draw 4 amps for 40 hours before the battery fully discharges. That's part A. And the second part reads, how many days will it last if it's discharged at 1 milliamp? Again, we can use the same equation, which is 160 amp hours is going to give me the current multiplied by the hours. So 160 is going to give me the current. We're saying it's discharging at 1 milliamp, 1 times 10 to the negative 3 multiplied by the number of hours. So if I divide 160 by 1 milliamp, I get a total number of hours of 160 times 10 to the power 3 is going to give me the number of hours that this battery will take till it's fully discharged. Now, how can I get how many days that will be? I should then be able to just divide this by 24. And that's going to tell me how many days it would take for this battery then to fully discharge. So if I divide this by 24, I get a value of I get a value of H equals 666.66 days, right? And we can further perhaps just get that better. So let's maybe take that to a number of years. How many days are in a year? So we can divide this by 365. So if I divide this by 365, then it will tell me that the number of years, this was the number of days, the number of years then will give me 18.26. So this battery, which is rated at 180 amp hours, if the current is 1 milliamp, basically it will last me 18.26 years until it's fully discharged. And this is a typical example where you'd be using the battery dimensions or the battery ratings to then determine the performance of the battery. Thank you for watching this video and enjoy the course.